So this first one, let me take this problem right here. Let me drag it down to where I got written work. This is a pretty cool thing. Back up, look at this problem. All right, so first step, always draw out ray diagrams so you kind of have an expectation of what should happen. And if I were you also, if I struggle with this, I'd go ahead and maybe write down what I expect the answers to come out to, greater than 1, negative 5, that sort of stuff, just to make sure it matches up. So here, this is a convex lens, so a ray that comes in parallel does what? Tracks to the focal point. All right, good. A ray that goes through the focal point does what? Tracks parallel. And a ray through the center does what? Okay, so I expect to find my person. Here's a head, right? And then the feet were on the principal axis. So just kind of writing down what I expect to have happen here. V. What can you tell me about the image distance? Positive, negative? Positive. Should be positive. And what else do we know? Is it greater than or less than focal point?
Greater than.
I'm expecting this picture is pretty conclusive. Since it's much farther than the focal length, I can conclude that it should be greater than focal length. By the way, if it comes almost right at the focal length, the only way that's going to happen is at a certain location, but I'll get to that later. Then you'd want to say around the focal length. Don't try to judge, oh, it's a couple of centimeters beyond the focal length. The math gives me a couple of centimeters before the focal length. Oh, no, don't worry about that. But I expect this to be greater than that, right? What can you tell me about M? All right, so it should be, M should be greater than,
It's negative.
it should be negative or positive?
It would be positive, so you have to put a negative in front of whatever your V value is, and that's negative multiplied by a positive over positive.
All right, so I expect this to come out to be flipped from where it's X, right? So that's going to be, is this coming upright or inverted? What is this image?
Inverted.
That's upright. I expect this to be a positive number and greater than positive 1. Right? That is what I expect here.
But it does that when you go to
I expect this to
height becomes positive.
I expect this to come out to be a positive magnification here, right? Upright. We'll deal with that in a second. I also expect H prime
to be positive because
we'll get to it. It's going out to be, I expect H prime to be positive, right? And I also expect this to be greater than 0.7 meters. Just look at this, right? And so those are some things that I can kind of make judgments on before I even start. So now let's do the math. Let's make sure the math matches up. First thing that's easiest to use here is my thin lens equation. 1 over the focal length equals 1 over u plus 1 over v.
Bring it all down.
Okay. So now that's 1 over 25 minus 1 over 30 equals 1 over v.
Okay.
So 1 over v equals, what's 1 over 25 minus 1 over 30?
I didn't see it, so I came out with 1.5. I came out with 1.5 years.
Here's something that we are not learning. Thank you, Tristan. I'm going to get to you next. You have to use your hands. You have to use your hands. Tristan, what is this 1 over 25 minus 1 over 30? 0.0063. I'm not done there, though. I'm not done there. John, make sure you get your hand when I call on this one, right? Because it's a good question. What do I need to do next?
Invert it.
Take the inverse, right? So whenever I take that inverse, v is going to equal what?
150.
I'm sorry?
150.
150. And what unit do I need to apply to?
Centimeters.
Centimeters. Now, to address the question, the units cancel out here. When in doubt, always convert back to base units. When in doubt, always convert back to base units. It will never hurt to go back to base units. Sometimes it's not necessary, though. This is an equation that is not necessary. There are no constants in this equation, right? Everything goes in as centimeters, and that's all I have, centimeters, centimeters, centimeters. Thus, since all the units are the same, and here I expect the answer to come out in centimeters. things that you generally can't get away with this idea. You can't get away with this idea with any equation that has a constant in it, because that constant is going to be based off of base units, right? You can get away with this. Let's say, let me go to something we are all familiar with F equals ma, Newton's second law. If you put the acceleration in, well, you couldn't really get that. F equals ma wouldn't work either, because you put the acceleration in centimeters per second squared, and you get something less than a Newton, right? You're not getting the full Newton out of that, so that's going to be a weird one. You could do it, let's say, with constant velocity, displacement over time. If you plug in displacement in centimeters and a time in seconds, you expect to get velocity in centimeters per second, right? But for the most part, convert back to base units, unless, like in this equation, you expect all of your units to cancel. Okay, all your units to cancel out. All right, well, let's see. V lines up with what I thought that it should, right? Positive, greater than the focal length. We're good. All right, so now let's talk about magnification. Negative V divided by U, right? So I can go ahead and tell you what y'all were saying is going to come out right here from what I was thinking at this time. Magnification equals negative 150 divided by, hold on a second here. Where's my U? 150. Oh, I got 30. 30, thank you. So what is that magnification come out? Negative 5. Now, let's talk about this. Why I assume positive instead of negative and why it is negative. What does that negative on the magnification indicate? What does that negative on the magnification indicate?
From where it used to be.
It's going to be,
Only when you flip
that's perfect. Yeah, good. It's going to be flipped. It's going to be flipped, right? Which it was flipped. It was just flipped down below on top, okay? So I was wrong on my thought here. It should come out, so this would actually be a less than sign, right, to get it down more negative there. It should come out to be a magnitude, something greater than 1, but it should be negative, okay? So magnification, negative 5. And now magnification also equals what? H prime divided by H, so negative 5, right, equals my H prime, what I'm looking for, H prime divided by H here, right, and my H is negative 0.70. Now, I don't have to convert here. I don't have to convert. Once again, this is a unitless thing, right? Magnification is kind of like the coefficient of friction, kind of like other things. It's just a ratio. This is a height in, let's say, meters divided by a height in meters. Meters cancels out, right? Giving you a unitless ratio number, right? So if I plug meters in, I expect to get meters out. If I plug centimeters in, I expect to get centimeters out. In doubt, when in doubt, convert back to base units. So what I'm saying to you, it kind of occurs to you, the example, maybe I don't have to convert units on this. But there's that little bit of doubt in your head. You don't think you remember perfectly. Daggone convert. Okay? It will never hurt you to convert back to base units. It will only save your thoughts. Alright? Whenever it comes to different problems. Alright, so convert back to base units. And remember, converting back to base units is hard. Just use scientific notation, right? Just tack on the times 10 to the third, times 10 to the negative second, whatever it is. By the way, not converting back to base units for either of you on that test that I'm grading right now. Okay. So where does this height come out to be? 3.5? 3.5 meters. It is positive, which is what I expected, and it's greater than the other height, 0.7. So everything here is lining up just right. Let's go back and let's check for sig figs. I can already tell you that I want to give you an extra sig fig. Let me put a period behind that 30 centimeters. If there wasn't a dot behind that 30 centimeters, how many sig figs would I be allowed? 1, right? I have to go back and round everything off to 1. So I would have had to say 4 for the height, magnification, negative 5, and that would become 200 centimeters. That's terrible accuracy. You would have to go back and check for sig figs, though, if that's what happened to you. So this becomes 3.5. That becomes negative 5.0, 150 centimeters.
And on the exam, we need like in the answer box, we need to put like student work answers.
The way I do it, there won't be a designated answer box on the IB exam, right? There'll just be, those IB problems I've been giving you, that is an actual IB exam, exactly how it looks. And those spaces that you write on are the spaces you're going to write on in paper 2 also, okay?
So they have the actual box.
Yeah, there won't be an actual box here for you to write in, if I remember correctly. Okay, if I remember correctly. And I need to go back and look at that before I hardcore to this, all right? But I believe that's the case. You would want to write, as you're working, work it out with great precision, way too many sig figs, right? And then round at the end for correct sig figs, circle or box that answer, right? And if there is an answer box, only put the sig fig one in with correct units, please, right, in that box. But on your work that you show it, you have the less precise number 2, or the more precise number 2. All right, questions on this one? Next one. Come down here. All right. Drawing free body diagram, or not a free body diagram, a Ray diagram for this guy to try to figure out what's happening. This is a concave lens, double concave. So first off, do I expect my image to be real or imaginary? Imaginary, every time. Do I expect this image to occur on the left or the right? I expect it to occur on the left, right? I expect it to occur on the left. Do I expect, what am I trying to say here? What do you know about the magnification of this? Give me a guess. You might not be sure of yourself here, but. Good. It will always be smaller with a concave lens. So even before I draw this out, I've already got an idea. Okay. A ray that comes out parallel refracts how? Good, as if it came from F1, right? As if it came from F1. A ray that goes through the center does what? Keeps going. And what's that next rule?
It says as if it's going towards F2.
And it doesn't. Good. As if it will go through F2, like that, it will refract out parallel. I need to trace all of these backwards.
Yeah, really? You don't need to trace anything backwards.
So I'm going to have this dinky little person somewhere around here.
Wow.
Okay? Teeny tiny.
Back that up a little bit.
Yeah. The
Sorry.
green line kind of just like dropped.
Yeah, you see where the two red lines intersect?
Then a dot of red lines.
Okay.
Yeah.
Somewhere around here, and my drawing isn't precise. And that, listen, this is okay. The person's going to end up X marks the spot. Okay? The person's going to end up there. Yes, right. You need to be able to draw ray diagrams with great accuracy if they require you to on the IB exam. Now listen, if they require you to do it with great accuracy on the IB exam, what they're going to do is they're going to give you a table, right? Not really a table, basically a piece of graph paper. Okay? They're going to give you this nice piece of graph paper. You'll pick a scale, let's say, like in this, 25 centimeters, 30 centimeters, and then I know I'm probably going to have to get over here 25, 30 centimeters also, maybe a little bit more, something like that. If the graph paper only has 50 blocks going left and right, I have to pick something, a unit smaller than 1 centimeter equals a block. I might be, 1 block equals 2 centimeters sort of scale, right? So you pick a scale that's appropriate where everything will fit just fine. And then you'll use that scale to make sure things are lining up just right. Use some sort of straight edge whenever you do that too. You can use another page in the test, right? You can use an answer booklet from previous. You can use any sort of straight edge you can find to make sure things are going well. And then lines will match up there as well. But whenever we're just doing it for the sake of showing the rules to make sure we're able to get right math answers, who cares? Okay. Let's just go ahead and jump to the math here. We've got our array diagram. We talked about predictions. I want to double back into the predictions, kind of working reverse of how we should. But we haven't done the diverging ones yet. So first thing I'm going to want to do again, there will be problems where you have to work backwards. Right now we're just working forwards. We're just doing the thin lens equation and magnification with distances, magnification with heights. We'll find problems where you have to work backwards through that process. Okay? 1 over the focal length equals 1 over v plus 1 over u. Doesn't matter if you get those split plot, right? Now, this is a diverging lens, so that focal length isn't 25, it's negative 25. Good. Negative 25 equals 1 over v plus 1 over 30. So this is going to be 1 over negative 25 minus 1 over 30 equals 1 over v. So you stick those two together, you take the inverse, what is it? Negative 14 unit. Yeah, let's stick to the dot 30. Negative 14 centimeters. Is that what we expected? Yeah, it is. Whenever an image, whenever the image is on the other side, if it's the same side as the object, I expect it to come out to be negative. Okay? Images on from how I have it drawn, the left-hand side, right, the same side as the object, that's the wrong side, so to speak, right? In other words, the image, like, it's almost like it's being reflected. Now, it's not actually being reflected, right? It's the eyes tracing the light rays back through the lens. But it's on the wrong side, you know? Thus, that's the negative side. So v equals negative number. By the way, let's go ahead and let's get these predictions now. Magnification, positive or negative? Should be positive. This is an upright image. Greater or less than 1? It should be something smaller than 1. So it's a positive number, and let's see, less than 1. 1's greater than m. And let's see, how about h prime? Positive or negative? It should be positive too. And yeah, it's something smaller, so h should be smaller than 0.7, right? Just a few predictions that we can put down here. So let's go to magnification. Magnification equals negative v over u. Yep. So magnification equals negative of my negative 14 divided by 30. So m equals a little less than 0.5, 0.46 approximately. Now I can come over, magnification equals h prime divided by h, so that's 0.46 here. H prime divided by, where's my h here, 0.7. So what does h prime come out to be?
0.32.
All those answers line up with what we expect? Yeah. So we should feel pretty good about this. Yep. Awesome. Good stuff. Sorry.